There's a teachable moment, I think, for any lawyer listening to this or anybody listening to this. At the end of the day, this case really came down, if you just distill it down to its scientific essence, this was a case about a company being held responsible for algorithmic decision-making, right? And we got to be thinking not about the cases we've been working up and trying for the last 20 years. We got to be thinking about the cases we'll be working up and trying 10, 20 years from now. And this is where all of this is going. It's critically important to understand how this stuff is stored, how it's analyzed, how it's processed.
I'd love for you to unpack that a little bit more.
Sure. At the end of the day, when these machines make decisions, they have to perceive the world. They have to make predictions. They have to have confidence in those predictions. And then they either have to act or not act. That's really all it is. We can make it sound way more complicated, and they do a fantastic job of that. But this is true in all forms of artificial intelligence. At the end of the day, it's about a prompt, some stimulus, it's a perception to the stimulus, and it's a decision-making to do or not to do. That's it. And when you break it down like that and go after these corporate witnesses about that, they have to concede as much. You know, when I would use language like this and talk about it in these simplistic terms, I would be routinely laughed at by Tesla's lawyers. Counsel, you don't understand. And they'd pat me on the head, right? You know, figuratively. But that's what it is. What we have to look at is you have to be able to drill into that. And the only way you can do that is with access to the actual data itself, not the summary, not the table of contents, but the actual words of the story. To that same end, neural networks, right? I take the director of AI at Tesla. You know, neural networks sounds like a fancy, you know, really complex idea.
It does.
It does. And it's not. It's pattern recognition. You want to teach something how to stop at a stop sign? You need to show it 200,000 stop signs in 200,000 locations at 200,000 times a day at 200,000 different weather conditions. And then sooner or later, hopefully, the system starts to figure out, oh, that's a stop sign. I need to react to that. That's all it is. That's all it is. They're just going out there, just training. It's machine learning. It's like when I taught my kid how to swing a baseball bat or how to shoot a free throw. He's got to do it 1,000 times.